So we're going to do some investigation of gases. Not that we're going to investigate greenhouse gases in particular, but you have to know about gases and maybe how to make them and investigate the properties of them before we can understand more about problems like greenhouse gases. And so we'll look at how they're made in the lab and we'll investigate some properties of gases. So what properties might we want to know about? Some physical properties. Just read the list there of the physical properties. And then some chemical properties. What type of things are we going to react the gases with? And here are some other questions you could ask. If the gas was in a balloon, would the balloon float? Is the gas soluble in water? What's the pH? What's its appearance? Does it smell? What's its density? Is it flammable? And is it poisonous? And so what gases do we want to know about? So pause the video and then list a few of them. And here's a list, some in red, some in black. One group of them are soluble, one is insoluble. Pause the video and decide which group is which. And here's the list sorted out into the black and red list here. And some are more soluble than others, and some are less soluble than others. There isn't a single solubility at a particular temperature. And then we're going on to see how we would make the gases. And in the lab, one useful set of equipment is called a gas generator. Here we've got a round bottom flask with a side arm and then a tap funnel going through a stopper into the flask. And really the clever thing about these reactions, they occur by adding a liquid to a solid. Sorry, that's the dog. The solid would be put in the flask first, and then the liquid would be added, and the gas would lead out of the side arm, the delivery tube, to a particular collection method. And here we have 6 different gases and what the liquid is, solution, aqueous solution with water, and what solid is in the flask. And what you're going to do is pause the video and write the equations for the reactions. You've got the reactants, you've got one of the products, determine the other product, and for number 2, there are actually 2 other products, and see if you can write the formulas. And there'll be some help a little bit further along with the equations written, but pause and write as many as you can. And some preparations require heat and care with them. The 2 here, you're producing toxic gases, so you have to do them in a fume hood, and it should be done every time by a qualified chemist. And here you have ammonia made from 2 solids, and the equation is written at the bottom with the state symbols, though the calcium chloride has got AQ there because water's formed, some of it would stay as a solid. When you make your gas, you've got to decide how you will collect it, but it depends on the properties of the gas that you're collecting. So if it's soluble in water, you're going to displace the air in the gas jar upwards, particularly if it's a denser gas like chlorine, and then you'll remove the gas jar and put a lid on it. There still will be some water there. It helps if the gas is insoluble, because you bubble the gas through water. There's downward displacement of the water, and albeit wet gas, but you just have the pure gas there, no gases in the air mixed with it as well. And what would be useful here is to look at a video of, choose one of the gases and put in your search engine, making, for example, ammonia in the lab, and you'll see a video of it. Does the method look easy? Write down why not, and what safety precautions were taken, would you need to take to make the gas that you have chosen safely. And you might like to look at more than one video there. You can pause it or write it down to look at later. Almost better to do it now. And then the other properties of your gas, you can perhaps write it down for the one that you've just seen the video of. Physical and chemical properties were described in an earlier slide, so you might want to go back to that. Toxicity, you can look at how they measure toxicity and whether the gas is poisonous, dangerous, whatever. How flammable is it? Does it burn? Amount produced, used, what it's used for in the US and around the world. And what about some fun facts for the gas? And here's just looking at pHs, and you can pause the slide here to look at the acidity and alkalinity of some gases. And then again, you can pause to read this one, some solubilities. Hydrogen, not very soluble at all. Oxygen, 0.04 of a gram in 100 grams of water, but it's definitely enough for fish and other aquatic animals. And wow, look at ammonia at the bottom. And pause to look at the suggestion for the curious to find out a bit more to research solubility of gases. And here we're just looking at this thin layer of our atmosphere. Gases are important. It's going to be atmospheric height of about 60 miles, 96 kilometers, and getting very thin, not very dense in the outer atmosphere. An incredible photograph. And here we have the equation writing. And again, you'll get helped with some of them, but you've already met single displacement reactions, double displacement reactions. There's a decomposition here as well. And remember, when you're balancing, you've got to have the same number of atoms on either side of the equation. At the bottom it says chemistry is magical, but it isn't magic. We can't make them disappear or appear, although strangely enough, things might go transparent. They might appear to disappear, but the atoms in a test tube will still be there unless it's a gas escaping. Thank you for sharing this. Don't hesitate to contact me with any questions, and enjoy your further survey of gases.